Welcome, dear student. Myself, Mudit Sharma, Assistant Professor from Mechanical Engineering Department. Today, I am going to discuss the new topic of my subject, Production Technology, which name is Gating System. So, it is very important subject for the casting. Actually, I am teaching to you two units parallelly, first and second. So some topping occurs from first unit, some topping occurs from second unit. So that is the mixture of two unit. uh, so what is gating system? Our topic is gating system. What is gating system? Gating system, it is the passageway in the mold for carrying the molten metal to the mold cavity is known as the gating system. Okay. So you can study in this PPT all the channel or passes through which the molten metal is delivered to the mold cavity term as gating system. It include runner, riser, pouring basing and gate. You can see in systematic diagram. You can see in the systematic diagram a gating system. A poorly designed gating system result in casting defect. It occur. A gating system control mold filling process. The main function of this lead to molten metal from ladle to the casting. Okay. So what are the common requirement of a gating system? First is the metal should be flow smoothly into the mold without any turbulence, because if turbulence occur during the flow event, there is a escaping gases occur in a molten metal, that why porosity occur, which causes casting defect occur. Second, we can say the mold should be completely filled in the smallest time possible without the having to the raise metal temperature nor use a higher metal head. That mean molten metal maintain its state and its cooling rate is high when the mold cavity is completely filled. The gating system should ensure that enough molten metal reaches the mold cavity. The metal entry into the mold cavity should be properly controlled. The metal flow should be maintained in such a way that no getting or mold erosion takes place. Unwanted material such as slack, dross and other mold material should be not be allowed to enter. These are the common or ideal requirement for the gating system. You can study in this PPT. I already talk about these. Restoration of the molten metal least turbulence, disturbance and turbulence. Facilitate the complete filling mold cavity. Develop such a temperature gradient a molten metal should within the lead direction solidification. Prevent the entry of the slag. I already talk about these. These are the some common defects which occur due to improper gating system, like oxidation of the metal, cold shut, mold erosion, shrinkage, porosity, mission, penetration of liquid metal. These are the common casting defect which create due to improper gating system. Now, what are the type of gate we use? Depending upon the orientation of the particle plane, vertical gating system and horizontal, depending upon the position of in gate, yeah, we can say gate. Horizontal gating system is subclassified in three system: top gating, bottom gating, and parting line gating. Okay, so what is top gating or bottom gating? Top gates are usually limited to small and simple mold or large casting. It is not advisable for the light or oxidizable metal like aluminum, magnesium. Second one is bottom gate. Bottom gate are used in this case. Turbulence or mold erosion are so least, time taken to fill up is so more. In this gating system, we achieve directional solidifying is difficult to achieve because of the metal continue to lose heat into the mold cavity. That's why this gate are best suited for large size casting. Now next is our parting line gating system. As the name indicates, the metal entered the mold at the parting plane when the part of the casting in the cope and part in the drag for the mold cavity in the drag it is top gate, and for the cavity in the cope it's bottom gate. Thus this type of gate tries to drive the best for both types like bottom or top. This is most widely used for sand casting. I hope you will understand all these gates. One another gate we also use in casting, that is step gate. Step gating system. In step gate, the metal enters the mold cavity in number of ingates or gates which are arranged in vertical step. The size of ingates are normally increased from top to bottom such that metal enters the mold cavity from the bottom most gate and then progressively move to the higher gate. It ensures gradual filling the mold without any mold erosion. These are mostly used for heavy or large casting. I hope this another gate we also discuss. So these are the systematic diagram for above discussing gate like top gate, bottom gate or parting gate. This is the review. Now, what are the common elements we use the gating system? Pouring cup, screw, screw bell, cross gate or runner, in gates or gates. Okay, so we will discuss one by one. What is pouring cup? It is the funnel shape opening made the top of the mold. The main purpose is pouring basin to direct the flow of the metal. Second is screw. It is a vertical passage connect the pouring basin to the runner or ingate. It is generally made tapered downward to avoid aspiration of air. The cross section of the screw may be square, rectangular or circular. Next is screw bell. It is located on the base of the screw. It arrests the free or fall molten metal through the located. Next is runner. It play very important role. It is a long horizontal channel which carry molten metal and distribute to ingates. It will ensure properly supply of the molten metal. Gates we already discussed and its different kind. Now next is the pouring time. It is a very important thing in the gating system. What is pouring time? It is nothing but the time taken for the filling the mold cavity by known quantity of metal. That is pouring time when the molten metal is being poured into the mold at a very fast rate. When the pouring rate is very low, complete filling of the mold is not assured and may result excessive drop. The type of metal size and shape casting decided by the pouring rate. Okay, these the guideline we use for designing the gating system. I hope we already talk about this in our PPT. You will study for your exam purpose. Thank you so much I hope you will understand why we use gating system. Okay, what are the common gating system we use? Yeah, how can we gating system be classify? There are two type of the gating system. One is pressurized, next is unpressurized. In pressurized gating system, the ingate serve as a choke. This system maintain a back pressure and cause the entire gating system to become pressurized. In unpressurized, the sprue waist serve as a choke. The typical gating ratio in this system can be 1 ratio 2, ratio 2, 1, 1 ratio 2, ratio 4, like this. So I hope you will easily understand by this PPT video what is gating system. For your better understanding, we add one animated video of gating system. Thank you so much. I hope you will study.
We know that in casting, as we pour the molten metal through the ladle, the metal flows across different elements before reaching the top of the riser. The section from the ladle till the riser is called the gating system. Thus, gating system refers to all the elements associated with the flow of molten metal from the ladle to the mold. The different elements associated with the gating system are pouring basin, sprue, runner, gate, and riser. Now let us briefly describe each of these elements. Pouring basin acts as a reservoir. It collects the molten metal which is poured from the ladle. Note that one of its wall is inclined about 45 degrees to the horizontal in order to absorb metal momentum and to prevent vortex formation. Also note that the pouring basin should be filled completely with the molten metal in order to prevent the formation of funnel. Sprue is a vertical channel through which the molten metal comes in contact with the parting line from where it enters the runner and the gate to reach the mold cavity. Note that the channel is tapered at the bottom in order to provide low pressure area to the molten metal. Runner is a horizontal channel located at the parting line to allow molten metal to flow smoothly from the sprue to the mold cavity. Gate is a small opening through which the molten metal enters the mold cavity. Note that gate should be designed in such a way that it can be broken easily after the casting solidifies. And riser is a reservoir of molten metal. It is used to feed the casting during the solidification process in order to prevent the formation of shrinkage cavities.